Hey, welcome back. So one of the things that I've noticed is the output of certain models in certain scenarios is actually getting worse rather than better. In fact, if you want to cheat on your homework, you probably better stick to ChatGPT or even Llama 2 or Claude Opus rather than using the new Claude 3.5 Sonnet, Google Gemini, or even Llama 3. And in this video, I'm going to explain why. So to understand why the models are getting worse, we need to understand just a tiny little bit of what's going on in a large language model. So the first thing to understand, and you'll have seen this before from one of my other videos, is that large language models don't see words directly. They have to be tokenized first into essentially a number representation of each word or subword. So if I take something like the query, who is Ada Lovelace, it would get translated into this tokenized input. And you can see there each word or even sub words in some cases would be split up and they would have a corresponding number in the dictionary. So it could be 1 for start of sequence, who is 11644, and that all gets split up and you'll get a list of associated numbers in the vocabulary. So when I talk to the large language model and I do a thing called a forward pass, i.e. I'm going to try and run my query through all the layers of the model, I'm not sending the English text directly, I'm sending the tokenized version. And that's going to hit a thing called the embeddings layer. And within that embeddings layer, it will actually have an entry for each item in my dictionary. So it's a big dictionary lookup table, and you'll see here something like who is Ada Lovelace. And within that is this massive vector associated with each token. And that is what the model is going to use. And it will take all of the entries of those vectors, and then it's going to translate it so that it can then pass through the things called the attention layers. So once you query the model, you're essentially going to pass the tokens into that embedding layer, and it's going to pull back that vector representation of the entire query. So it's going to grab the vectors for each single item within the query. And then essentially you're going to work through all of those attention layers, essentially just doing a pass through that layer through layer through layer, and then eventually you're going to get to the end output and you're going to get a new tokenized output, which is going to tell you the result. It'll say something like Ada Lovelace is blah blah. Now the key thing to understand about attention layers, or transformer blocks in this sense, is that when I hit those layers, that embedding, that vector that is pulled from the embeddings layer, is actually split into 3 vectors. The first one is a query vector, the second one is a key vector, and the last one is a value vector. Now, the query vector is essentially a way for the token to ask questions about other tokens in the sequence. So it's really allowing you to figure out in something like the question, who is Ada Lovelace, which tokens it should pay most attention to. One of the other vectors is generated is the key vector, and the key vector is used to represent the content and the significance of each token in the sequence. And again, keys are matched with queries to measure the relevance of each token. And then finally, each token will generate a value vector, and the value vectors are the actual information or representation that will be combined to form the output. These are the 3 key things, and they are projected from the embeddings. And of course, as you work through the attention layers, then you're sort of getting this kind of layering effect, and you're just working your way through the network. Now, these 3 blocks form the key of what's going on here, because in a standard transformer block, since the original paper, there was this idea of multi-headed attention. And what you can see there in multi-headed attention is you're essentially going to process the inputs by splitting them into these smaller parts, these heads, and then you're going to attend to each part independently. So they're going to run through the model and they're all going to be looked at independently, and then eventually you're going to get this value. Now you see in multi-headed attention, there's this one-to-one mapping going on. So I've got my queries, my keys, and my values, but there's a one-to-one between queries and values. Now what this means is for any output that's multi-headed attention, you're going to get this really comprehensive and integrated answer because you're referencing various parts of the passage. They're all being looked at independently, and then you're going to summarize everything with an overall relationship and impact accurately. So multi-headed attention is given a really good integrated response. Now, what's actually happened in some of the newer models, so things like Gemini or the Gemma models, they've actually moved to a thing called grouped query attention. And it comes from a paper. Again, I'll put the link up here and you can go and look at that paper yourself. But grouped query attention actually means that it's going to use less values and less keys, and they're going to share across the queries. So what you, and again, the clue is in the name, which is grouped query attention. Essentially, what's going to happen is you're going to have groups of keys and values, which are then shared with queries. Now, if you think about that for a second, that means that certain topics need to get grouped together and you're looking at less information at the same time. And the impact of that is that group query attention means that it's focused more narrowly on specific queries, and therefore the results are going to be less integrated and they are essentially going to be a more fragmented, less coherent response. And in fact, if you look at the models, you can generally tell what a grouped query attention output model looks like, because it's going to look very list-like. It's going to seem very chronological, and each part of something like a story is going to be segmented, and it won't have an overall narrative story to this. And that is the problem that I'm talking about. So if I look at something like ChatGPT and I give it a piece of text to summarize, it's going to do a beautiful job. It's going to integrate it all well together. It's going to create a cohesive, beautiful narrative, and that's great. But then if I run through maybe on a Gemini or a Gemma model, then what's actually going to happen is I'm going to have this really chronological, narrow focus piece. So what does that mean? That means if you have something that is a long piece of text and there's a lot of rich relationships within that text, then it's likely any model that's using group query attention will miss out on those richer relationships. It will miss out on the broader story. It will focus in on narrow elements of the passage, whereas a multi-headed attention model is really going to get that broad context, that overall story arc is going to get that spot on. And that's the major difference between these models. Now, GPT-4o has stuck with multi-headed attention, but Llama-3 is running group query attention. Llama-2 used to run multi-headed attention, but they switched to group query attention. The Gemini models and the Gemma models are all using group query attention. The Mistral models are using group query attention, and the Claude models, we don't know. But I suspect, and I'm going to prove this to you in a second, that the old Claude 3 opus model was a multi-headed attention, and I believe the new sonnet model architectural change has moved to group query attention, and you can see it, and we're going to prove that in a second. So why would they change the architecture? Well, the quick version is that, as you can kind of see, that if I'm running smaller groups, i.e. I'm halving the groups, then I'm going to get faster inference. And a lot of the model providers are really wanting to push forward for faster inference. They want to have essentially smaller models. They want to do more with less, and they're really pushing towards that. So that fast inference is really what's driving the changes from most of these models. But obviously GPT hasn't switched to that, and they haven't switched to that on the Omni model as well. So how can we prove, how can we tell if a model is running multi-headed attention or group query attention? Well, actually the thing that we really need to do in these cases, we can design ourselves a prompt that will expose the architecture of the model. Now, I'm not saying that this prompt is perfect, But what I decided to do is construct a little story about a bakery in a village. And when I say I constructed a story, I got ChatGPT to generate this story for me. So this is a story about a baker named Thomas. He created this amazing bread every day. It was a unique flavor. And Thomas, there's lots of descriptions of what Thomas would do throughout his day in bakery. And then, of course, one day, Thomas met a new baker, a new traveler called Henry, who was down on his luck, and Thomas decided to help Henry out there and teach him how to bake, and then they worked together, etc. It's a really lovely story. But at the end of it, we're going to ask the question, what was the role of the traveler named Henry in the bakery's success, and how did his relationship with Thomas evolve over time? And the reason I've picked this particular one is it's a long enough prompt. I don't want it to be too big. It's just over around 500 tokens, but it's enough of a size where if it is a group query attention model, it is probably going to get chronological. It's going to focus on a paragraph by paragraph. It's going to segment, and then it's going to miss the overarching story. Whereas a multi-headed attention model will deal with the story arc as a whole and tell a very sort of integrated story as opposed to going paragraph by paragraph. And now if I want to, I can just run this through something like GPT-4o, and you can see I ask it that question, and then it's saying Henry played a pivotal role, and then it's going to come back with, a couple of answers about how this was impacted. So that's GPT-4o's type response there. It's coming back. It's going to be a pretty good response, but I need a way of essentially judging that. So what I've done in this scenario, I've actually taken, and again, I'll share this code here. I've actually taken the outputs of every single model, and I've put it into this folder called input. So you see I've got Claude 3 Opus, Claude 3 Sonnet, Gemini 1.5, Gemma 1.7b, Gemma 2 9b, Gemma 2 27b. I went through some of the key models that I want to look at that I know have made architectural changes, or ones that I don't know the architectural change of. And then I've just essentially ran that prompt that I showed you 2 seconds ago against these models, and then captured it and stored it in this input text. So the second thing that I've done is I've created a script called rank outputs. And what that essentially is going to do is going to run through all of that input folder there, so you can see iterate over each file in the directory and read the contents. And then I'm going to send this to GPT-4. And you can see it comes back with the following is an original prompt, several responses to it. Please rank the responses based on their coherence, fluency, non-segmented, relevance, completeness, and quality. And if I wanted to, I could just run that on my Python. So I'll just say Python rank outputs. And then you can see all that it's essentially done is got that nice little response there. It gives the original prompt, that story that we talked about, and what the question was, and then it gives the responses of every single model that it's concatenated there. And again, you could go and test this for yourself, pull all of the outputs. So that's fine. So I've taken all of these outputs here, I put that in this file. And then if I want to, I could just copy and paste all of this, and I could run this on any model, but I'm going to pick GPT kind of 4o. And then if I just paste that in here, and you can see based on the criteria of coherence, relevance, completeness, and quality, here is a ranking of responses. So it's came back with GPT-4o as being highly coherent. It's came back with GPT-3.5, highly coherent. Llama 270b. Remember what I said before? I said that Llama 2 was a model that was using multi-headed attention, and then they switched to group query attention. Look here, it is ranking higher than Llama 3 based on this. And then we've came back with Claude 3 Opus. And again, that's pretty good there. Again, very coherent. Now, Llama 3 has made it in at this point. In fact, we're seeing some of the group query attention models coming in. But you see it's already calling out that it's lacking sort of depth, and it's calling out segmentation. So I can make this prompt a little bit better. This time, I'm going to ask it to penalize for segmented responses, i.e. outputs that are highly chronological, segmented, and chunked. So it's the same prompt as I got before, but now I'm going to put a higher penalty on segmentation and non-chronological integrated ones. So let's have a look at it. Again, it's got GPT-4o at the top. It's still got GPT-3.5 there. There's Claude 3 Opus still coming too. But look now, Llama 2 is still there. Llama 3 8B is interestingly high up there. Claude 3.5 Sonnet is there. Llama 2 7B is pretty high up. So if we look at the results here now based on that, you see GPT-4o is still at the top. GPT-3.5 is number 2 according to this. Claude 3 Opus is at number 3, highly coherent, etc. Llama 2 is rocking it ahead of all the Llama 3 models. Actually, interestingly enough, the next model here is Llama 3 8B. And then you see Claude Sonnet and then Llama 2 7B. Now that's really interesting because we know Claude Sonnet is probably group query attention. Llama 3 is definitely group query attention. And then Llama 2 7B appears there. And again, that's multi-headed attention. Now, one of the things to kind of be aware of, and again, I'll probably do a separate video on this. I did an experiment, or rather, one of my colleagues, Jeremy Conaway, actually did an experiment. He took all of the outputs and he ran it through a tool which checked the readability of the outputs. And when you check that for readability, actually all the smaller models did better than the larger models. And again, multi-headed attention sort of beat that through as well. But if we look here, you can kind of see what's going on here is that the smaller models, which will have better readability than the larger models, even though their group query attention are kind of coming through there. And I think that's really sort of interesting. And then there's Llama 2 back there, and then Gemma 2, which is a smaller model. But things like the newer Llama 3 model, 70B, it's down on 9 at the moment. Mistral models, all much, much lower. Gemma 1, which is a multi-headed attention model, is doing better than some of the Mistral models. It's doing better than Gemini 1.5 Advanced. And then, of course, Tiny Llama is a terrible model, so it's not doing so well. But the new Gemma 2 model sitting smack bang at the bottom there. Now, the next thing that I did here is I asked it, now, which ones do you think are multi-headed attention versus group queried attention? So, and by the way, I think it made a pretty good judgment on this. You see here, multi-headed attention is saying GPT-4o. It's saying Claude 3 Opus, Llama 2, very coherent, GPT-3.5. By the way, all of these we know are multi-headed attention models. Well, we don't know Claude 3 Opus, but I think it's a pretty good indication that that is multi-headed attention based on what it's saying there. Again, Mistral next, we don't know what that model is. We know that certainly the Mistral and the Mixtral open source models are group query attention, but we don't know if these ones are GQA or MHA. However, if we come down in here, look, it's picked up Llama 3's GQA, is somewhat segmented, chunk processing approach, Mistral large. You've seen somewhat segmented, suggesting GQA. So remember what I said at the beginning of the video, that Claude 3.5 Sonnet, they've went for a different architecture. In fact, even Claude 3 said they've made some architectural changes. So as good as Claude 3.5 Sonnet is, actually, if you're generating text from this, probably making your stories worse. Yeah, because it's going to be segmented, chronological, and it's not an integrated storyline. Again, Mistral 7B, it's picked up, that's GQA. It's picked up Gemini 1.5. This is one of the top models, but it's so low down there. Tiny Llama is MH, and so is Gemma 1.7B, but they're so small of models that I just don't think it's going to pick it up here. And again, ambiguous, it's saying Llama 2, Llama 3, and Mixtral. And again, these are all smaller models, so it's probably done that. So if I really wanted to push it really hard, I could probably do an even bigger story rather than the 500 tokens. So to bring this back to the beginning, I believe that certain model creators are making trade-offs, and they're trading off the speed of their model versus the quality of their outputs in certain scenarios. So if you are using a model to create generative outputs, maybe it's content creation, maybe it's creating summarizations of articles, then you probably want to be leaning towards a model that's using multi-head attention as opposed to a model that's using group query attention. And as you can kind of see there, those group query attention models, although they are getting faster speed for certain scenarios like summarization, for content creation, the model outputs are demonstrably worse. And they are worse because they are segmented and they're not presenting an integrated outline of the story. And it's just something that you need to be aware of. Now, that's not to say that that architecture doesn't work in other areas like code creation, classification, etc. But for content creation generation and summarization of large chunks of text, then that narrow focus that group query attention has might run you into some problems, and therefore the speed that you get from that model might not be worth the trade-off. So you see the model providers are making those trade-offs already. I think Claude 3.5 Sonnet has made that trade-off and has moved to GQA. However, what will be interesting is with Claude 3 Opus, whether they stick with an MHA architecture. What is really cool is GPT hasn't moved at all. So one of the things I would love to see the industry do off the back of this video is actually incorporate this into benchmarking, because I don't think that is being considered today. So anyway, I hope this video has been useful. And in a future video, I'm going to talk about the discovery that myself and Jeremy made that the smaller models are outputting more readable outputs than the larger models. And again, I think that's an interesting segue. And on that, I'll catch you on the next video.